Okay, welcome America. We're going to be doing two problems today with rational functions. It's our review day, but it's graphing. We're going to be practicing all the properties, all the information that we need for graphing, but not actually graphing rational functions. Okay, let's start. So we're going to be doing numbers 3 and 4 on the Analyzing Rational Functions worksheet, which I'm going to attach. So we'll start with number 3. So before we can start, we need to factor. These problems are asking you to just fill in this information here for each of these equations. So we'll go ahead, and before I can do really any of that, I notice there's a trinomial in the numerator and a trinomial in the denominator. So I'm just going to go ahead and factor both of those, because you never know what will happen when you factor. Okay, I have got, is that x plus 1 and x minus 5? I think that works. Because x times negative 5 is negative 5x, and then 1 times x is 1x for a total of negative 4x's, and then 1 times negative 5 is negative 5. So we're good. Questions on factoring? All right, let's do the denominator. That's going to be plus plus. And 4 and 1. Because for the outer and the inner, we have 1x plus 4x for a total of 5x, and then 4 times 1 is 4. We good? On the factoring. Okay, let's look at it. Well, now we've got a factor in the numerator and a factor in the denominator that cancel, which means we have a whole. We have a whole or discontinuity at, I'm running out of room, let me move this over here. Our x coordinate for our whole is negative 1. I'm going to rewrite this equation over here. That's what's left once I remove the x plus 1 in the numerator and the denominator. So now our whole, or our removable discontinuity, has an x coordinate of negative 1, because negative 1 plus 1 makes this 0. To find the y coordinate, all we have to do is take this negative 1 for x and plug it into leftover equation for x and just see what we get for y. So since we're already halfway done, we'll just finish that now. So negative 1 minus 5, negative 6 over negative 1 plus 4, and that's going to be 3. So we're at negative 1, negative 2. Any questions on that? A lot of people have trouble with getting the y coordinate for the whole. A lot of people can get the x coordinate and then forget how to get the y coordinate. Is everybody good with getting the y coordinate? You find the x coordinate, you plug it in to what's left of your equation here. It's usually a lot less work because there's less, and there's only one factor left in the numerator and the denominator. Okay, so now we can do the asymptotes. We really don't want to start with the asymptotes here because one of them ends up canceling. We don't have an asymptote there. We have a hole there. We only have an asymptote, a vertical asymptote at x equals negative 4, not at negative 1, right? Because there's a hole there. So vertical asymptote, x, bless you, equals negative 4. How are we doing? You guys are quiet today. Okay, so now let's move to horizontal asymptote. What's left here is x minus 5 over x plus 4. We have the degrees the same in the numerator and the denominator. So what does that tell us about the horizontal asymptote? What's it going to be when the degree is the same in the numerator and the denominator?
1.
Yep, because it's the leading coefficients for each of those. 1 over 1, so it's just 1. Why am I writing on this one? Haven't done that one yet. Okay. Y-intercept. A y-intercept is always on the y-axis. So that means the x-coordinate is going to be 0. So it's going to be 0 and then something. So we're going to plug in 0 for x and see what we get for y. In this case, when I plug in 0 here and 0 here, I get -5/4. So the y-intercept is at 0, -5/4. And the x-intercept is going to be at what makes the numerator 0, 5. When I plug in 5 for x, I get 0 for y. Good? X-intercept is at 5, 0. And I think I filled out all the information I needed. Move on? One more problem. We gotta do long division. Este es muy importante. Okay, so factor. Numerator. Denominator is already factored. So 2x plus 1, then x minus 4. Because 2x times x is 2x squared. 2x times minus 4 is -8x. 1 times x is 1x. So -8x plus 1x makes -7x's. And then 1 times -4 is -4. Any questions on how that was factored? The denominator is still x minus 2. We don't have anything that cancels, which means we do not have a whole. So I'm going to write none here. Well, this is clearly very easy to tell. The vertical asymptote is at x equals 2. And if you look at the degree, now this is important, between the numerator and the denominator, the degree of the numerator is higher than the degree of the denominator, which means we are going to have a slant or an oblique asymptote, not a horizontal one. And that means we're going to have to do long division. Yay! So let's start. Technically, you can do synthetic with this problem. You know what? I'm going to do this problem both ways and just make it super long, because why not? Okay, let's start with synthetic. It's much easier to do synthetic. Where is the 0 at? The 0 is at 2. 2 minus 2 is 0. So, synthetic is kind of like an upside down division sign with all the leading coefficients. 2x squared minus 7x's minus 4. Bring the 2 down. 2 times 2 is 4. And in synthetic, we are adding the numbers, not subtracting. In long division, we're subtracting. So we've got -3. 2 times -3 is -6. And I'm hoping you guys watched my video. And what this means is we've divided, this 2 was the leading coefficient for 2x squared. We just divided an x out. So we divided an x out. This 2 is now the leading coefficient for not x squared anymore, it's just for x. So the slant asymptote is at y equals 2x. And then minus 3. The minus 10 at the end, I'm just going to show you what this means, but you don't need it right now. That is the remainder. This is the remainder. You don't need this part right here, right now. You will need it in calculus. Really, why we don't need it is because as x approaches infinity, the denominator, this is getting smaller and it's approaching 0. So we don't really need that right now. Nick?
Can you only use synthetic division when there's one term in the denominator?
Yes.
Okay.
So the problem that we did last class had like an x squared plus 2 or something, so we had to use long division. I'm going to show you how to do this with long division, what it will look like. But anytime you can use synthetic, use it. It's much quicker. So here's what this problem looks like. And in my video that I did, synthetic versus long division, I did one problem both ways. So here's what long division looks like. 2x squared minus 7x minus 4. This is just like when you do long division with numbers. I'm running out of room over here. X minus 2. So what times x gives me 2x squared? That's going to be 2x. It's going to go above the x's right here. 2x times x is 2x squared. 2x times negative 2 is that, did I do that right? Yeah. 2x times negative 2 is negative 4x. Someone tell me if I make a mistake. Now, in long division, we have to subtract this number. So instead of just putting a parentheses and a subtraction out in front to make sure we subtract, I'm just going to change both of the signs of these and just do it right there with a different color. So I'm going to make that a minus and this a plus. And that makes this, those are going to cancel, and I'll have negative 3x's and then minus 4. And that is going to make this up here negative 3, because negative 3 times x gives me negative 3x. Negative 3 times negative 2 gives me a plus 6. And then those will end up, when the signs change, those will end up canceling. And 2 will be a remainder, we won't need it. But notice we're still getting the same, wait, not 2, negative 4 plus negative 6 is negative 10, which is the same remainder from the last one we did synthetic. We're still getting the same equation here. So this is a little bit more work. All right, so let me write this in. I just had a student in calculus this morning during pride time ask me how to teach her how to do long division for a calc integral problem. So you will need this. Okay, so we've got if I take a look at the numerators, where can I, what can I put in here to make this 0? What can I put in here to make this 0? We've got, those are our x-intercepts. So that's at negative 1/2, 0, and then 4, 0. And the x-intercept is, when I plug in 0 for x, I get 1 times, just make sure that's right. Is that at 0, 2, my y-intercept? I want to make sure that's right before I before I close out my video. In my notes I have negative 2, but I know that's not right. Okay, any questions? Going once? Going twice? Nick, are you gonna correct anything before I close up shop? Okay, thanks for coming out. Happy St. Patrick's Day. I'm so sorry I did not wear green today. Like, really, I apologize. So I put on some green.